All right, so today I'll explain about question 7. Okay, question 7, from what you can say is we have this one, the joint probability of x and theta. Okay, so x and theta, they are the two different random variable we are given. Okay, so we have x equals to 5, theta equals to 4, and then we are given this probability b minus 0.01. Okay, so b is an unknown that we don't know. We want to find it. Okay, so same goes to this one as well. Probability of when x equals to 9, theta equals to 9 is equals to a. Okay, so this is another constant that we have to find. So we have two constants that we need to find, a and b. Okay, but it will be impossible for us to find without any extra given name, without any extra information. So okay, we are actually given this one, the absolute difference between the variance of x and then the variance of theta is this figure. Okay, so my thought process is this one. So first thing first, we have to find the expectation of x, okay, the first moment of x, and then we can proceed to find the second moment of x, okay, and then lastly, we can find the variance of x, okay. So how do we find the expectation of x? So it's actually just the marginal one, okay, because now we are given the joint, right? We have to make them into marginal, okay. So later I'll illustrate in the table how do we make them into marginal, okay. So same idea for variance of theta as well. We find the expectation of theta, and then the second moment of theta, and then lastly we get the variance of theta. Okay, so at the end we have to use a function which is called ABS to find the absolute difference between the variance of x and the variance of theta. Okay, and then I am sure we cannot get the same answer in the first try because we have this one. We have our b here and our a here. So okay, it's very obvious that we cannot get exactly same as this one, but we can actually use the solver function as Excel, okay, to reverse engineer so we can get our a and b. Okay, so let me illustrate all my thought process in the Excel. So what I do is, okay, I create a marginal table. Okay, so this one is for x, okay, and then for the side is for the theta. So what do? I just insert the probability. Okay, let's say for this, when x equals to 5, theta equals to 4, okay, your probability will be b minus 0.01. Okay, so how do I insert b? Okay, so for this case, right, you look at my formula. I actually use this one. Okay, C10. C10 corresponds to the b value minus 0.01. Why am I using C10 actually? Because I actually don't have any value of b. Okay, so I just assume a cell is the value of b. So later I'm gonna use the solve function to work backwards, so we can solve that. Okay, so just all the formula, the corresponding probability there. Okay, so now we will start with the x first. Okay, when x equals to 5, we will get all the probability of x equals to 5. Okay, which is where? Which is this whole column here. Okay, so I just use the summation function, get all the columns. So do the same thing for 7, 9, 14, and 17. Okay, nothing is hard here. Okay, and then we are trying to find the expectation, right? Okay, we are trying to find the expectation. So it's basically using your x multiplied by the probability of x being chosen. Okay, so corresponding b13 multiplied by c13, which is my 5, multiply the probability of x equals to 5. So 5 times 0.12, okay, you'll get 0.6. Okay, that's pretty simple. So we do the same thing for 7, 9, 10, 14, and 17. Okay, so x power of 2 multiplied by p x equals to x. This one is to actually find the second moment. Okay, so do the same thing, but for now, you have to square your x value. Okay, you have to square your x value. So what do you do now? To find expectation, right? We just take the sum of this number. Okay, sum of this column, we just take it. And then for this one, expectation, a second moment, we just take this whole column here. Okay, just write them down here. And then we use the formula. Okay, the variance equals to the second moment minus the first moment square. Okay, this one is our very important formula here. Okay, so we can observe that when I try to get the total probability, right, I'm getting 0.41. So 0.41 is actually a big issue because we have to know that, right, for all the probability of x, okay, you should get 1. okay, you should get 1. So this is another trigger for us. So later we can work on that thing. So same thing we do for theta. So theta, we have 4 possibilities, right? 4, 6, 7, and 9. Okay, just do the same thing. We take all the probability, which is this whole row right here. This one is for the theta equals to 4. So as for theta equals to 6, okay, it's the same thing. Just take the everything. Okay, theta equals to 7, take everything. Okay, theta equals to 9, take everything. Okay, so you have all this information here. So we do the same thing as we did for x. To find the expectation of x, we just take the summation of theta multiplied by the probability of theta equals to theta. Okay, so same thing for the second moment. Okay, so you take the theta and then you square them. So observe here, I square my theta and then just take the moment. Okay, I just take the sum of it. Okay, and then I'll get this one result. So I'm trying to work on the question. The question told me, right? Difference between variance of x and variance of theta. So I try to find, okay, just using the function of ABS to find the absolute difference, okay, and then use my C23, which is my variance of x, minus my H23, which is my variance of theta, okay. So you can observe, I'm not getting a correct answer, okay, I'm getting 18.0475, which is pretty logical, because why? We don't have the value of A, we don't have the value of B, and then our total probability here, this one, they are all messed up. It should be 1. But why am I getting 0.41 only? Okay, so we can work from that. Okay, so when we want to work backwards, we have to use this solver function. Okay, if we are using this solver function, okay, so let's say I delete all the other functions first. So okay, we have to set our objective first. Okay, so the first thing, I set my this C18 cell as my objective, which is my total probability. Okay, the value should be 1. Okay, the value should be 1, not 0.41. So which cell should I change? Okay, I should change my A and B. So I can get somehow, okay, I can relate them to the question. Because my end motive is to get A and B. Okay, so just solve the equation right now. They found a solution. Okay, they will find a solution. Okay, so now for this problem, it's solved. Okay, my probability equals to 1. Okay, so that's one okay, that's one trouble left. So now we can work on this one. Okay, the probability should be this one. 19.47 485663679. But what do we have? We have 18.3249. So it's very wrong here. So I think we can use another solver function. Okay, so just okay, for this one, our objective should be our cell C25. Okay, which is our absolute difference between the variance of x and the variance of theta. Okay, so just set our value into the given value in the question, 19.48563679. Okay, which one are you changing? Okay, you are still changing the A and B cell. All right, we are still changing the A and B cell, guys. Okay, and then we have to add our constraint here. Okay, we have to add one constraint. What is the constraint? Okay, we must make sure this one, our total probability is equal to 1. Okay, this one is for the x. Okay, so we can add one more. Okay, we can add for the total probability of theta is equal to 1 as well. Okay, so this is very important. So when we have our constraint, we try to solve them. So let's see what can you give us. Okay, so this is our correct answer. Okay, because why? We have satisfied our condition. Our total probability equals to 1, and then our absolute difference is the same as the one given in the question. Okay, so we can know that our A and B value, they are incorrect answer. Okay, so I think that's it for the explanation for this question. I think it's quite interesting, this question, because we are using solver function to work backwards. All right, so thank you for everything. Bye bye.